So hello again, this is the Swift for Arduino blog, and this is another really simple little project for demonstrating the use of the counter rather than the timer. It's actually in combination with timing as well, to measure the speed of a fan, to measure the RPM of a fan. So again, here we've got a 3-wire fan, just a regular PCB fan, and you've got 2 wires going in, which are the power, the black and red. The 3rd wire, the yellow wire, is the tachometer, and if you raise that voltage up by applying it to an input pull-up or something like that, or a resistor up against the positive rail, then this will provide pulses twice per revolution due to a built-in hall sensor that's built into the fan. You'll find this on a lot of fans. Any 3-wire or 4-wire fan will have this. We've seen this in one of the other projects that I've got on the blog, which is the strobe synchronized with the fan, which is a great fun project. So recommend you go and have a look at that if you haven't already. Anyway, today we're doing a much simpler idea. So all we've got here, if you look, we've got the fan, we've got some power coming in from the bench power supply there, which I'm going to hook up as 12 volts because it's a 12-volt fan. And then the ground rail here is just running back to ground on the Arduino. This here is going into pin 4 of the Arduino, and that's quite important that it is pin 4. You'll see why in a little bit. And that's hooked up to the tachometer here. And then just to give some extra interest, I've got an oscilloscope here also attached to the same thing, and that's the ground wire on the oscilloscope. So really just a very simple setup. Probably looks more complicated than it really is. The oscilloscope's just there to measure it so that we can cross-reference the values that we're getting against the oscilloscope. So now if we go and look at the code, so this is a really simple piece of code here. So let's start at the beginning. Okay, so we've got some serial printing stuff here at the top. Sorry, there's some lunatic shouting outside the window. Apologies, that's because I'm taking a video in central London. So the first thing we need to do here is set up serial. We're printing a welcome message, like, you know, hello, fan RPM monitor. And we've got a function here because I want to pass in the RPM, and then I just want to, it's really simple, just want to print out the RPM value and the word RPM, just to make it easier to read. And with the print functions that you've got here, in order to construct it, we don't use printf with Swift for Arduino because it could cause memory issues. So what you do is you do print with add new line false, and then that will run the RPM value, and then it won't do a new line, and then we'll print the message RPM, and then that'll do a new line after that. So that's just a really simple function. You can build up your print statements like that on the serial port or wherever you're sending it to. Now we'll get down more into the bulk of it. So firstly, we'll set pin 4 as an input pin, and we'll raise it high, as you can see there. And that's important because then that activates the pull-up resistor, which raises the voltage of the tachometer, and the hall sensor will short it to 0 twice per pulse. So that'll give us a nice pulse, which we'll be able to read on the oscilloscope in a little bit. And here's the critical function that actually activates the system in question. So we've got this thing here called the timer naught set as counter function. And we're doing that on a rising edge. You could do it on a rising edge or a falling edge. So all this does is it basically sets timer naught to not really be a timer, but just be a counter. So it will just count up. It won't go at any particular pace. It'll go whenever the pulses arrive. Could be one every second. Could be whenever. They could be, you know, at any point. It could be like clicks on a button, and that then allows you to read a value of counter 0 as to how many pulses there have been since the last time you reset. Then to get the RPM, obviously we need to find out how many pulses per unit time. So we go back to a function that we used before here, which is set up the timer interval callback. And we're doing this every 100 milliseconds. So every 10th of a second, we're going to check the value of the counter And so this just basically counts how many clicks from the hall sensor you've got in a tenth of a second. And then to turn it into RPM, it's a fairly straightforward calculation. You actually get 2 pulses per revolution. So that means that the number of rotations per second is this count times by 5, and the RPM is then this count times 300. So we just set the value, we leave the value 300 here in a constant. Because this is Swift for Arduino, everything has to be done carefully with types. The compiler is much more careful than C. This is one of the things that prevents you from tripping up, prevents you from having unintended side effects because it's such a strongly typed language. So it's really strict about the types that we get here. This is a uint 8 value that's coming back because it's from timer 0, which can only run from 0 to 255, and when they'll loop back to 0 after the counter goes up to 255. And so we have to cast this as a uint 16, and then we multiply it by our multiplier. And as I've mentioned on previous videos, in order to get a non-aborting multiplication, we use this AND times, and that means in the unlikely event that you were to break the bounds 65535, so it's pretty unlikely that we get a value anything like that high, but if you were to do so, then it would just wrap to 0 silently and not abort as Swift normally would, because Swift is safe by default. So this gives us a uint 16 value which will run from 0 to 65,000. Your fan is not going to be running at 65,000 RPM. Typical fan values will be somewhere between 3,000 and 5,000, something like that, RPM. And then we call our function that we've mentioned before to print the RPM, and then we reset the counter so that it's reset for the next one. And that's it. That's all we need. So if we upload that, you can see that's uploading. And this is running here. And now we can see it's running at 0 RPM because the fan is currently turned off. If I turn the fan on, so we've now got 12 volt supply going through. You should quickly start seeing, yeah, that's running at 2,000 RPM, 3,000. And it's picking up speed as it goes. And here on the oscilloscope, you can see the trace for the fan tachometer, and you can see that that's running at about 130 hertz, which if you multiply it up, remembering that you get 2 pulses per revolution, comes out to about the right value. And that's, again, a proof of how nice and simple it is. There's just much less complexity than there would be, or much less risk for issues than there would be if you were writing this in C, because everything has to be typed correctly, and you can't get any buffer overruns because everything's kind of keeping you in the right bracket. So you can do what you need to do, but it's just easier to write code that's going to work. And there's a nice simple RPM monitor for you. If you haven't already got it, then go to our website, www.swiftforarduino, to download the latest version of the IDE, which is currently version 12 at the time of writing, and get started writing Swift on the Arduino today.